Now we're going to talk about the square root property, which is another method to solve quadratics. So we've already talked quite a bit about one of the methods you can use to solve quadratics, and that is factoring and the zero product property. So just as a reminder really quick, if you want to go back, you can watch the video on that again. But in order to use the zero product property for factoring, it has to be factorable and our equation has to be equal to 0. So I'm going to start by factoring out a GCF here, which would be a negative 5x, and that will leave me with x minus 5 equals 0. So either this negative 5x is the 0, or this x minus 5 is the 0. So if I solve the first one, I get x is equal to 0, and if I solve the second one, I get x is equal to 5. And those are my two solutions using factoring and the zero product property. So a second method that we can use is what we call the square root property. Now this particular method of solving can only be used in certain situations. So we can only use it if there is no b term. So remember with quadratics we have ax squared plus bx plus c. So in this case we can't have this middle term where we just have x to the first power. So if there is an x to the first power like this, we can't use the square root property. Another thing to remember, and we've talked about this quite a bit, is that we have to isolate the x squared before we take the square root of both sides. So for instance, if I had x squared minus 4 is equal to 0, before I can take the square root, I have to get the x squared all by itself. So I would have to have x squared is equal to 4, and then I can go ahead and take the square root of both sides. So this would give me plus or minus 2. Okay, so here's our first example of using the square root property. You can see we have no b term. So the first thing we need to do is isolate x squared. So we're going to go ahead and move the 12 over. So we have x squared is equal to 12. Now that x squared is isolated, we can go ahead and take the square root of both sides. So that gives us x squared is equal to the positive or negative square root of 12. Now remember with radicals, unless it asks for a decimal approximation, we're going to leave them in exact form. So we need to simplify this. Remember, I can break this apart into the square root of 4 times the square root of 3. And then since the 4 is a perfect square, I can go ahead and take the square root of that. So this would be 2 square roots of 3. So x is equal to positive or negative 2 square roots of 3. And remember, since we started with x squared here, we are expecting 2 solutions to all of these equations, which is why we need this plus or minus. Okay, so this next one we can also solve using the square root property because there's no x to the first power. So we're going to start by isolating x squared. So this means I have to move the 25. So 9x squared is equal to 25. But it's still not isolated. I still have to get rid of the 9. So I'm going to divide both sides by 9. So I have x squared is equal to 25/9. Now that doesn't reduce, so I'm just going to leave it as a fraction, and I'm going to go ahead and take the square root of both sides. So I have x is equal to plus or minus, the square root of 25 is 5, and the square root of 9 is 3. So this gives me positive or negative 5/3. Okay, so next let's look at x squared plus 16. So again, I want to get rid of this plus 16. I want to move it to the other side so that I can have my x squared isolated. So x squared is equal to negative 16. And then I want to go ahead and take the square root of both sides. So I have x is equal to positive or negative. Now remember, I can treat this as the square root of 16 times the square root of negative 1. We know that the square root of 16 is 4, and we know that the square root of negative 1 is I, so this is plus or minus 4I. So anytime I have a radical or a negative under that radical, I'm going to have I in my answer. So this next one looks a little different, but I want to show you how it's actually very similar. So normally we would think that maybe we have to go ahead and FOIL this and then go ahead and try to solve it from there. But what you can see is that we actually have a square term all by itself. So if I were to take the square root of this x minus 3 squared, this square and this square root would just cancel each other out, leaving us with that x minus 3. Well, if I take the square root of the left side, I also have to take the square root of the right side. So the square root of 16, remember, is plus or minus 4, positive or negative 4. So now all I need to do to isolate x is just move that 3 over, and you're always going to make sure to move it in front of that plus or minus sign. So x is equal to 3 plus or minus 4. Now since these are nice whole numbers, we can actually figure those out. So the first one we have 3 plus 4, so that gives us x is equal to 7. And for the second one, we have 3 minus 4, so that gives us x is equal to negative 1. So our two solutions are 7 and negative 1. So this last example is similar to the previous one. Notice that I have this quantity squared right here. So if I were to simply take the square root, I could cancel out that square. The problem this time is that this is not isolated. I have to get that by itself, which means I have to move this 3 over first. So I have x plus 1 quantity squared on the left, and on the right now I have 5. So now that the term being squared is completely isolated, I can go ahead and take the square root of both sides. So on the left, the square root and the square cancel, leaving us with x plus 1. And then over here, there's nothing I can do to simplify 5, so I'm just going to leave it plus or minus the square root of 5. So all I have to do to isolate x is move this 1 over. Again, it's always going to go in front of the plus or minus. So that gives me x is equal to negative 1 plus or minus the square root of 5. So those are my two answers, and remember, I can't add and subtract those because one is under a radical and the other is not, so I just have to leave it like this. And remember, I could separate these out if I wanted to just write two answers. I could have x is equal to negative 1 plus the square root of 5, and x is equal to negative 1 minus the square root of 5. And those are my two answers. So this is two different ways of writing exactly the same thing.